Hello. This video is on Chapter 6, Cost Volume Profit Analysis, CVP, which I think is probably one of the most useful parts of this course. It basically allows you to look at your fixed and variable costs and your revenue and determine how many units you need to sell to break even. And then you can also determine how many units you need to sell to make a certain profit. So we're going to be looking at what's called variable cost, fixed cost, and mixed cost. And we're going to be looking at a concept called contribution margin, which contribution margin is the sales price per unit less the variable cost. And so we're going to talk about the variable cost, fixed cost here in a minute. So cost behavior is the manner in which cost changes as a related activity changes. So as you sell more chicken sandwiches, your cost of your buns and chicken and your lettuce and whatever else is on that chicken sandwich, they increase. And knowing how costs behave allows managers to predict profits as sales and production volumes change. This is also on a relevant range. Normally, a company is going to project sales, and then from that, they're going to project everything else. Cost to get sold, production schedules, etc. But it's over a relevant range. For instance, Chick-fil-A a few years ago started adding a second drive-through window. Before they added that second drive-through window, they might have liked to have sold, 1 million chicken sandwiches a day, but they just simply did not have the capacity. So you have to determine how much you are expecting to sell, and then you have to make sure you have that capacity. So these figures are only relevant over that range of profitability or of the volume that you can actually do. Variable costs. These are costs that vary in proportion to changes in the activity base. So looking at a chicken sandwich, if you don't sell any chicken sandwiches and you don't have to throw away all of your food, then you really have incurred zero cost from a variable cost standpoint. Now, if you sell one chicken sandwich, then you're going to have the chicken, the bun, the lettuce, the mustard, whatever. And so every chicken sandwich you sell is really going to be a cost of those components. And if those components, let's say in this case, $10, then the variable costs per unit aren't going to change. So that chicken sandwich is going to cost them $10 every time. Now, there may be a little adjustments in adding other sauces or whatever, but for that particular chicken sandwich, every time you sell that one, it's going to be $10. And so if you sell one, your variable costs are going to be $10. If you sell two, your variable costs are going to be $20. And you can see here. So if you sell 5,000 units at $10, then you're going to have direct material costs of 50,000. And if you have 10,000 units times 10 is 100,000 is going to be your cost. So variable cost in total will increase as your volume increases. But per unit, it is going to stay the same. You can see here. So volume went from 5,000 units to 30,000 units. Variable cost went from 50,000 to 300,000. So your ratio is going to be, again, you're assuming that over that relevant range, your cost per unit is going to stay the same. So as you produce more units, you're going to have higher variable costs. But the per unit cost is going to stay the same. And here's the variable cost in their activity is university, instructor salaries, number of classes, etc. All right, so fixed costs are the opposite. If you're a Chick-fil-A, then you basically have to have a building, you have to have a dining area, you have to have a kitchen, you have to have drive-through windows, you have to have computers, you have to have ovens, etc., electricity, insurance. So these are costs that you have, whether you produce one unit or whether you produce 10,000 units. And so those costs are, again, opposite of fixed variable costs. Your fixed costs are going to stay the same no matter how much you do. So that Chick-fil-A, you have to staff it at a minimum level because you're expecting customers. But that building is not going to cost you any more if you do 1,000 customers versus you do 10,000 customers. So the fixed costs are going to be the same, but the per unit cost is going to decrease as volume increases. And that's just simply mathematics. If your variable costs were $75,000 and you do 50,000 bottles, then the per cost unit cost is going to be $1.50. It's just 75 divided by 50. But you can do up to 300. So now you're spreading those fixed costs over a wider volume. Fixed costs again stay the same. So just mathematically, the more volume you do, the lower your fixed costs are going to be per unit. So you want to hit that optimum point. And a lot of times in manufacturing, it's 80%. At 80%, you can't run a factory at 100% all the time because you've got to have maintenance, things break down. So 80%, you're going to look at that volume and you're going to find the sweet spot, so to speak, where you're not under capacity, but you're not over capacity. And so here's your fixed costs. Again, your fixed costs are going to be the same over that relevant range. They're not going to change. But then the more you do, the less it's going to be per unit. There are some, fixed costs of university. The more students you have, the more you're able to utilize those spaces. So the cost of those spaces per student decrease. And mixed costs are sort of a combination. It would be similar to if you had a cell phone plan where you paid a fixed amount for up to, say, 2 gigabytes of data, and then you paid an additional amount for anything over that 2 gigabytes of data, then you would have a mixed cost. You'd have that fixed cost, but then you have a variable component that would only come into play if you use that much. So here are some hours used here as an example. So here, if you only used up to 8,000 hours, you're going to pay 15,000. But if you do 12,000, you're going to pay $17,000, which is your base uh, of 15 plus the additional hours. Okay, so that's mixed cost. Now here's some business insight booking fees by this entertainment. Here you got Taylor Swift. They pay her $1 million just to show up. I think that's probably more because let's face it, she's a billionaire and she had to get there somehow. Justin Timberlake, he's run into some problems lately, but $1 million just to show up and sing. Of course, he's got to pay all of his musicians and all of the stuff he has with his show, but he probably still walks away with a good penny. And you can see here Rihanna and Katy Perry and get down to the script, which I have no idea who they are. I do know who Keisha is. Pitbull, I actually like him, and Bruno Mars. Carrie Underwood, I like her, but $400,000 to $500,000, even after paying musicians, isn't bad. So here's a way to determine what your variable costs are. And basically, you just go and you look at, all right, if we did 1,000 units, our total cost was X, 1,500 X, and you're going to take your highest and lowest. So your highest was 2,100 and your lowest was 750. And so what you're going to do is say, okay, what were my costs here? What's the difference in the cost from going to 750 to 2100? And so it's 20,250, and the number of units is 1350. And so that basically will tell you what your variable costs are. You'll look at this difference in your total cost divided by the difference in units produced, and you've got $15 per unit are considered your variable costs. So the fixed cost is estimated subtracting the total variable cost from the total cost for each unit produced. All right. So your total costs are 61,000, and your variable costs are 15,000. We produced 21,000 units, so our fixed costs were 30,000. Here our total costs are 41,250. We produced 750 units times our variable cost of $15. We subtract the variable cost from the total cost, that gives us the fixed cost. And so here is just, again, a summary. Variable increases and decreases proportionally with activity level total, whereas fixed cost in total remain the same, but the per unit cost variable stays the same. But the fixed cost, as you're spreading this overhead over more units, that will go down per unit. So you have variable costs, you have fixed costs, and you have some of these mixed costs. All right, so cost volume profit analysis is a management tool used to examine the relationships among selling prices, sales and production volume, costs, expenses, and profits. It's useful for management decision making. All right. So we have to introduce the concept of contribution margin. And what we're looking at is we're just looking at the variable cost. So let's look at that sandwich we made from Chick-fil-A. And let's say that we know that all of the cost of the ingredients would come out to somewhere around, let's say $5. And they sell that sandwich for $9. So the difference between the selling price and the variable cost is going to be what's called your contribution margin. And so that's your sales price of $9 minus your variable cost of $5. So the contribution margin on that sandwich could be $4. And I'm just throwing these figures out. All right. And we'll see here that you have sales of 50,000 units times $20 per unit is your sales price. So you're going to get revenue of $1 million. Your variable costs are 50,000 units times $12 or 600,000. So your contribution margin is going to be 400,000. Again, sales minus variable cost. Your fixed cost overhead are 300,000. So your operating income is going to be to 100,000. So we can come up with a contribution margin ratio, and that is really just like a gross profit in a way. It is your contribution margin divided by your sales, and in this case, it's 40%. And then you can use that to determine what your break even is. All right. See, the contribution margin ratio is 40%. When a change in volume is measured in dollars, the contribution margin ratio can be used to compute the related change in operating income. So change in operating income is equal to change in dollars times contribution margin ratio. So if we earned another $100,000, we should earn another $40,000 in profit, right? Change in operating income, change in sales dollars times contribution. Oh, we're only up 80,000. Okay, so 80,000 times the contribution margin ratio will give you the change in income. And you can see here that before we made 100,000, now we're making 132,000. And that's the $80,000 change in income times the contribution margin percentage. The unit contribution margin is basically, again, that $4 I was talking about. It was the sales price per unit, which from our sandwich was $9, minus the variable cost, which is $5, so that's $4. And then you can use that to determine your break even. In fact, we should have a formula coming up here pretty soon. And so we're going to skip to that to determine break even. All right, the mathematical approach to cost, volume, profit. So break even means that your revenue covers all your costs. You don't make any money, you don't lose any money. And the formula to determine that is break even unit sales units. So we're first going to determine the break even sales unit. Then we will multiply that by the sales price per unit to get the break even in sales. Now later on, we're going to look at how many units are break even if we want a certain profit. So the formula really is fixed cost plus desired profit divided by unit contribution margin. In this case, our desired profit is 0 because that's our break even. So it's going to be our fixed cost. Our fixed costs are 90,000. Our selling price is 25. Our variable cost is 15. So our contribution margin is 10. So we're going to divide 10 into this 90,000. And basically, we need 9,000 units to break even. Okay. And you can see that sales would be 225,000, variable cost 9,000 units times the variable cost of 15 is the contribution margin of 90. So that's the fixed cost of 90. And break even sales in dollars, you can do the fixed cost divided by the contribution margin ratio. All right. And so here, now again, here we're looking at 9,000 units times $25 per unit, and that gives us the $225,000 in revenue. You can also determine it again by your fixed cost divided by your contribution margin. That gives us the $225,000 in break-even sales. And what happens to fixed cost? Effect of changes in fixed cost. And let me show you one other thing here. Now you should think of a jar of marbles. The jar represents your fixed costs, and the marbles represent your contribution margin. So, how many marbles or break-even units, how many units do you need to fill this jar? So, how many units do you need to cover your fixed costs? As the jar gets bigger, which means that your fixed costs get bigger, then you're going to need more marbles. As the jar gets smaller, so in other words, your fixed costs decrease, the number of marbles or the number of units you need to fill that jar or break even decrease. So more overhead, you need more units, less overhead, less units. The marbles represent the contribution margin. And so the contribution margin is again sales minus variable cost. The bigger the marble, in other words, the larger the contribution margin, the less marbles you need. The smaller the marbles, so in other words, you will have a small contribution margin. The smaller the marbles, the more marbles you will need. So if you want bigger marbles, how do you do that? Well, again, you have sales minus variable costs. To make your contribution margin higher, you need to either increase your sales price or decrease your variable cost. That'll make your marbles bigger. Okay. And you can see here that again, this is a smaller jar with bigger marbles, so you don't need as many compared to this, a larger jar, so you have more overhead with smaller contribution margin or margin or marbles. Okay. So hopefully that gives you a picture of what we're talking about. So again, as fixed costs go up, your jar gets bigger, your break even, you need more marbles. As fixed costs go down, your jar gets smaller, you need less. Again, on your break even, this is your unit. So you want a bigger marble. Well, how do you get a bigger marble? If your unit variable costs go down, that means your contribution margin goes up, your marble gets bigger, you need less marbles. If your sales price goes up, that again increases your contribution margin and your marbles get bigger, so you need less marbles. Here is just sort of a breakdown of the different airlines. The lower number is better, so Southwest Airlines has a lower break-even point, so they're a more profitable airline. Again, selling price. If you want bigger marbles, increase your selling price. That decreases the number of marbles you need because the marbles are bigger. If you decrease your selling price, that means your contribution margin goes down. That means your marbles are smaller. That means you need more marbles. Here is just sort of a view, but again, I think it's helpful to think of that jar of the marbles. So target profit, like I said, when we were computing break even, this target profit is zero. So it's fixed cost plus zero divided by unit contribution margin will give us the number of units for break even. But now we want to make a profit of 100,000. So we've got to cover 300,000. So we've increased the size of our jar because we're no longer interested in break even. We're interested in making some money. And so we need to cover 300,000 units. And what is our contribution margin is 30. So 300,000 divided by 30 is going to be 10,000 units. And then we can prove this. Sales times 75 is 750. Variable cost are 450. That's again 10,000 units times the variable cost. That gives you a contribution margin of 300,000. You subtract your fixed cost of 200,000, and we have $100,000. All right. So again, same formula, but when you're looking at break even, this is zero. And then we just kind of look at some graphs here, and you can see where the overall, this are your total costs. Your total costs are going to increase. Um, this is your operating loss. But once you hit that break even, then of course you're making money. And here again is profit volume chart. All right. Really, all these are saying basically the same thing. You can use spreadsheets, which I highly recommend. And then special cost volume profit relationships. Sales mix. Okay. In this case, you're going to look at the contribution margin for each product. And then you're going to look at the sales mix for each product. And that's going to help you determine what your break even is. If you want to read about the baseball, this is why sometimes teams don't want to win. The Astros earned $99 million, but they didn't win the World Series. They weren't a good team because they weren't paying their players much. So here is the breakdown of selling price of M. So you have the product A, $90 is the selling price times 0.8 because that's 80% of it. And then you've got product B. So basically, again, it's the product times the percentage, okay, and add those together. And so your unit contribution margin is M. So if you have a product mix of 80% of product A and 20% of product B, and you have these costs, then you're going to need a total of 8,000 units. Now you multiply 8,000 times 0.8, and that will give you the number of product A, and 8,000 times 0.2, and that'll give you the number of product B. And then you can carry this out and see that that's break even. And then operating leverage is just a measure of, well, how much do you make? I was in the MRI business, and basically at that time we made about $1,000 on a study. But our fixed costs were huge. You're looking at a machine that was 1.5 to $2 million. You have to have special type of shielding because it's a huge, strong magnetic field. So you have to contain the magnetic field. Um, so you had this machine, and it needed capacity. So basically, we made a profit of $1,000 per unit, which means if you operate 254 business days, so for every patient above break even, we made $250,000. And so you can see here, but of course, every unit, every per day patient below break even, we lose $250,000. So that's a big operational leverage. And you can see here, same cells, variable costs are the same, but because of the fixed costs are higher, Wilson Company's profit is more. And so here's the operating leverage. So for every dollar of revenue, you're making, or your operating leverage is 5. So for every change in, so for every $10, you're basically making $2. Well, I'm not explaining this anymore better, but operating leverage can be used to measure the impact of changes in sales on operating income. Using operating leverage, the effect of changes in sales is computed as follows. So a higher operating leverage means that you have more risk reward. Okay. So if you only make $5, then you need a lot of volume to get to that break even. But if you're in the MRI business and you're making $1,000 per patient, you need 4 or 5 patients a day to break even. And then margin of safety just basically says, well, you know, how much can sales go down before I get to that break even point? And that really, again, is sales minus sales at break even divided by sales. And so you can lose 20% of your revenue before you start losing money. And that's it. This is a very useful concept. It can be used in manufacturing. It can be used in service. So, I've gone through most of the slides fairly quickly, but the formula is fairly simple. And if you, again, think about that marble, think about that jar, and relate that to fixed cost, variable cost, contribution margin, I think that'll help you understand.